All right, the other topic I want to do out of this section is parallel and perpendicular lines. So suppose you've got two different lines, and each of these lines has its own value for the slope and for the y-intercept. So these two lines are parallel if their slopes are the same, and they're perpendicular if their slopes are related by this equation here. It says that if you take one of them, notice what's going on here. If you take m2, this side over here is saying take the reciprocal and change the sign, and if that gives you m1, then the lines are perpendicular. So for instance, if you had the line y equals, say, 3/10 x plus 7, and you wanted to find all the lines that are perpendicular to it, those would be the lines y equals, change the sign and take the reciprocal, x plus b. So all of those would be perpendicular to, when I say all, I mean for any value of b you plug in here, this line will be perpendicular to the original one. Let's play with this on Desmos for a minute, just to get a feel for it. I'm gonna graph two lines here. Y equals, well, what the heck? We'll do the we'll do the one I just did up there. 3/10 x plus 7, and this looks like that. Now, if I put in, for that to be lowercase, not that it really matters. If I put in y equals minus 10/3 x plus b, what we get is a line that meets it at a 90-degree angle. And it doesn't really matter what my b is. That's just going to sort of move the line around. But all of those are, for any value of b here, these two lines are going to be perpendicular. Let's put in a slider for slope. Let's say the slope of this line is mx plus, well, let's say this line is y equals mx plus 1. If I want to draw a perpendicular line to it, it's going to be y equals minus 1 over mx plus b for any value of b. And so I'm going to move this up here. And if I start changing the slope around, it's going to move this around, but they'll stay perpendicular to each other. Oh, an interesting thing happens here. When I make the slope of one of them 0, the other line disappears. It's because 1 over 0 is undefined. Let's see. Anyway, so let's do some problems. Find the equation that's perpendicular to this line and has the same y-intercept. Okay, this is actually a really fast problem to do. If it's perpendicular to this line, we know that the slope is going to be -3/2. And if it has the same y-intercept, the y-intercept is 1. So the equation of this line is y equals minus 3/2 x plus 1. I'm going to rewrite that 3 so it's actually legible. And that's all there is to that problem. Let's look at this one. Find the equation of the line that's parallel to this line here and passes through the point 1, 2. Okay, well this line is not in, it's actually in the general form. So first up, let's find the slope. So we'll do that just by solving for y. So why is that going to give us a slope? Because if we solve it for y, it's going to be in the form y equals mx plus b, and we can just pull the slope out from there. So if I take 3x off of both sides, and then divide by -4, I get 3/4 x minus 3. Yeah, minus 3. Okay, so that's the slope of this line. The slope of my new line, well, they're parallel, so it's going to have the same slope, 3/4. but it says it's supposed to pass through the point 1, 2. So I'm going to use that for my x1, y1. And I'm going to plug into the point slope form. We'll get y minus 2 is 3/4 x minus 1. So let's see. So y minus 2 is 3/4 x minus 3/4. When I add the 2 onto both sides, 2 is 8/4. Cram that in there. So we get y equals 3/4 x minus, or actually no, now it's plus 5/4. And let's put that in Desmos just to double check that it's correct. All right, so the original line, I'm just going to put it in like this. 3x minus 4y equals 12. And the new line we found is 3/4 x plus 5/4. We get that. So they're definitely parallel. This one, though, was supposed to pass through 1, 2. So if we put the line, the point 1, 2 on here, sure enough, our green line does go through 1, 2. So we're good to go. So our answer is y equals 3/4 x plus 5/4. All right, this last example we're not going to do because it turns out it's involves some trig. I didn't realize that when I wrote the problem. So we're going to stop here for this section on linear functions.